I want to talk about a particular aspect of kinetic energy and work. So this is an conclusion that we have derived previously also, but again I want you guys to understand what is happening. It's basically we are talking about law of conservation of energy. It's actually listed later in the syllabus, but we are going to use it throughout the exercise and all of that, right? So I thought of letting you guys know this basic aspect, and we are going to make use of this, and we are going to get the kinetic energy formula, not formula actually, answers with this particular conclusion. Okay, so what is that I am talking about? The work done on a moving object is equal to change in the kinetic energy of the object. It's quite simple. This we already know. See, whatever work we do, it is converted to energy, right? This relationship we saw. Work we do, that is converted to energy in the other object. Whatever energy we spend is converted to work, is used up as work, right? This exchange of energies is nothing but your work. Now, if I have an object and if I increase the velocity, I have two different cases. If I have an object, if I increase its velocity, what happens? So if already it's moving and I make it move faster, so its energy increases or decreases? It increases, is it not? So kinetic energy initial, and this has a kinetic energy final. So the work that I do, where is it transformed to? It is transformed to the increase in kinetic energy, that is increase or decrease in kinetic energy. In this case, increase in kinetic energy. How can I find the increase in kinetic energy? All I have to do is subtraction. Final kinetic energy minus initial kinetic energy. Okay, that's it. So we'll get a positive answer. So we have done a positive work. Now, what if things are not in this manner? What if we have an object moving already with a particular speed, but we decrease its speed? In some cases, we can get it to halt also. In some cases, we can get it to rest also. I guess same thing, but we can get it to rest also. So what is the funda over here? Here too is the same thing. All we have to tell is the work that we do, that is the energy that we transfer, is seen as decreasing the kinetic energy. Here too we have kinetic energy of the object initially, and we have a kinetic energy final, right? Same thing. Yes, we need to subtract it, and yes, in this case the work is negative. We'll get a negative work. Here we get a positive answer. Right guys, I hope you are able to understand all of this. It's the same funda in a different form, that's all. It's the same thing. Whatever we learned about this over here, remember, a person pushing a block and all of that, we spoke about that, is it not? The same thing we are using it in a different form. Okay, so I'll repeat the entire thing. I think I was a bit fast. I'll repeat it. See, the note is about that the work that we do gets transferred into energy, and the energy that we spend is nothing but used up as work, right? So this idea we are going to carry over to do numericals on kinetic energy. So kinetic energy numericals can be of this aspect. Either you are looking at an increase in velocity after doing the work, right, after applying some kind of force, or it can be decrease in kinetic energy. Obviously, we are applying a force in the opposite direction of the motion. In both of the cases, it is a difference in the final velocity and the initial velocity that will be equal to the work that we do. Okay, again, the difference in the final velocity and the initial velocity is what the work that we are doing. It's equal to that basically. So I have a simple question over here. It's a textbook question only. It's one of the textbooks. The moving car has 3 kilojoule of kinetic energy. Okay, it already has that. So we have an object. If I want you guys to see it as a, let me not write this as an answer. Let me show it as an white car. Okay, we have a white car. A bubbly car. Let me make the tires a bit, yeah, that makes sense. So it is moving forward. Now it has a energy of 3000 joules. 3 kilojoules is 3000 joules. The driver applies the brake, okay, and car comes to a halt. So it comes to a stop somewhere over here. So basically it comes to rest. So we are applying a force in the opposite direction, not we, the brakes. So basically we can imagine that the car is being pulled or car is getting pushed, something like this. So if there is someone standing over here, say Superman or Hulk, trying to stop the car. So they are applying a force in the opposite direction, clearly, is it not? So what do you think the amount of force, or the not amount of force, how much work is done? How much work is done by this person or this force? What do you think it is? It's very simple. It already had this. Since it came to rest, it will end up with 0 joule. Because the velocity is 0. Rest means velocity is 0, is it not? Right? So conclude. Come to your conclusion. Come to a conclusion. Okay, what is that we are looking at? Yes, we have an object that was moving, which came to a rest. So the work that I do is spent as change in kinetic energy. Change in kinetic energy. So change in kinetic energy is nothing but any change, we can find it with finding the difference. Agree? Obviously, final minus initial. So this would be your answer, by the way. Work that we do is seen as change in kinetic energy. So change in kinetic energy is nothing but final kinetic energy minus initial kinetic energy. Final kinetic energy is half into mass of the object into 0 square. Okay, right? Or let me write it as v square itself, so that you have to write the formula once. And the initial kinetic energy is minus 3000 joule. That is directly given. So we'll write as the object came to a halt. As the object came to a halt, what happens? We can tell that therefore velocity, or the final velocity v, is equal to 0 meter per second. Okay, so we have this to be equal to 0 minus 3000. So this is minus 3000 joule. So the work done by the force provided by the brake is minus 3000 joule. Okay, so negative here indicates that the work is done against the motion. So you can write the negative value indicates the work is done against the motion. Work is done against the motion. This we know, right? We learned about work being positive, negative, or 0. Okay, so this would be your answer, right guys? So again, yeah, it's a very simple thing. If it's an MCQ question, it's very clear that it will be equal to minus 3000 joule. Just tick it off. But writing part, we need to give a theoretical explanation. This will be for 2 marker. If it's for 1 marker, then you guys can directly write work is equal to minus 3000 joule. Reason being this. You need not write so much. So depending on the marks, you guys have to, write the answer. So it will be either for 1 or 2 marker. Okay guys, but conceptually it has to make sense that work is nothing but change in kinetic energy of the object. So in this case, it is increasing kinetic energy. Here in this case, it is decreasing kinetic energy. So it's better to write it as change in kinetic energy. So let me write it as change of kinetic energy. This too is change of kinetic energy. It doesn't matter if it's increasing or decreasing, still it's change, is it not? Change of kinetic energy. Okay guys, so yeah, you guys have to write anything, not anything, everything, not anything. Okay, write all of this. In this, we need to write this as an example. You guys take it as an example. Don't write the question. Never write the question unless you feel that yes, it's very difficult. It's quite simple, is it not? You can start off with this. So it's moving with a particular velocity and it came to rest. You can write the scenario. You can just write it in your own words. Right? The car is moving and it came to rest. So U here is 0. So this picture makes it clear, is it not? And we are applying a force. So this meaning not, yeah, I think this is good enough. Agree? So we are applying a force and it comes to a stop and so on and so forth.